Hey, Shopping and Life's Math Industry, and we are going to take a look at the density. So, if you ever heard from chemistry, or possibly physics, or possibly biology, because even though density is a science-related subject, it has a lot of mathematics in it. And if you heard the phrase, if something is very dense, then therefore it feels very heavy, and if you put it in a liquid, it would sink. Well, this is what density is all about. How you can compare the mass and the volume. So for the math part, the formula for the density of an object is density is denoted as the letter P, and you have to divide the mass of the object by the volume of that object. The mass of the object explains how many particles are in that object. Like, here's a 3D printed version of one of the frisbees in one of the Vex games that we play for Vex Robotics. And you can see here that there could be like trillions or billions or blah blah blah, the amount of particles in this thing. That is the mass. And we measure the mass in kilograms and the metric system. Volume is a little bit different. The volume of an object is basically what's inside this object, or how much this thing can hold. So remember, the density is the comparison with mass divided by volume. So this is the mass.
What happened to the ship? It's big again.
Not as big as the moon's going to be.
What?
The larger the mass of an object, the quicker the effects of the shrink ray wear off. I call it the Nefario principle. I just came up with it now, actually.
Oh no.
Did you see that?
And this is the volume. So we are going to use an example when we would use this. So, if a power block's mass is 10 kilograms, so the particles within it is made up of 10 kilograms, and the volume, or how much it holds, is 3 meters cubed, what is the density? Well, we can apply that to find the density with the formula. So we're going to say, we're going to use the mass as 10 kilograms, and we have to divide that by the volume, which is 3 meters cubed. And when we do that, you are going to use a calculator, because how can you divide 10 by 3 in your head accurately? So when you do that, you get, we're going to say 3.33 kilograms per meter cubed. So that is the density. So that is how we can use the mathematics and the formula for density. But wait, we're not done yet. We can actually show an example where we can actually show how density works. Because if we were using a POW block as an example, as like the object for our problem, we're also going to use a wooden crate. And the thing about the wooden crate is, when Mario pushes that button right there, the two things up there will drop. There's a POW block and there's a wooden crate. Let's see what happens. So it appears that the POW block sank and the wooden crate floated. We're gonna explain how that happens and why, because that explains density right there. Okay, so we watched a POW block. We watched a POW block and it sank. We watched a crate and it float. The reason why the POW block sank is because it's more denser than water. If you saw the crate float, it's because it's less denser than water. So when you have a liquid come and play with density, water and liquids have their own density as well. Anything that is more dense than water is gonna sink, like that POW block or a rock. If anything that has less dense or is less denser than water, it will float, like a lily pad or a log or something. You can also experiment this with liquids. Let's say you have water in the middle. Something that's more dense than water is honey. Therefore, honey will go under water. Water will float above honey. If you have oil from a car engine, that is less dense than water. That means oil is going to have less dense than water and it's going to float on water. And that is why we saw the POW block sank and the wooden crate float. The POW block is more dense, the wooden block or the wooden crate is less dense. And that can explain density. I hope this video has helped you understand density. Thank you for watching Top Opinion Life's Math Industry. Like and subscribe.